Hello everyone, in this video we will learn about linear differential equations of first order and their solutions. We have already learnt about linear differential equations, what are linear differential equations in the previous video. And in this we are going to learn about linear differential equations of first order. There are two types of linear differential equations of first order. The first one is dy by dx plus py equal to q, where p and q are the functions of x or the constants. For example, suppose we have dy by dx plus 1 upon x into y equal to x square. Here in this equation, we find p is 1 upon x and q is x square. The second type is dx upon dy plus px is equal to q, where p and q are the functions of y or constants. For example, dx upon dy plus sec square y into x is equal to 10y. Here we find that p is equal to sec square y and q is 10y. So these are the two types of linear differential equations of first order. To find the solution of a linear differential equation, we need a particular function which is to be multiplied to the equation to find out its solution in an easy way. That function is known as integrating factor. How to find out that particular function? Let's see. Suppose gx is the function which we multiply on both the sides of the equation. Multiplying on both sides of the equation, we get gx into dy by dx plus gx into p into y equal to gx into q. This gx is taken in such a way, gx is taken such that the derivative of y into gx is equal to the right hand side of this, or we say equal to the left hand side here. So we write d by dx of y into gx should be equal to gx into dy by dx plus gx into p into y. If we differentiate this, we find y into g dash x plus gx into dy by dx. We have applied the product rule of derivative here. This is equal to gx into dy by dx plus gx into p into y. This gx into dy by dx cancels on both the sides. And then we find here gx into p into y is equal to y into g dash x. This y also cancels this y. And then we get the value of p here. P is equal to g dash x upon gx. If we integrate both the sides with respect to x, we are finding integral of p into dx is equal to integral of g dash x upon gx. We know this is derivative upon the function. The integral of this is equal to log of gx. So we can write here integral of p dx is equal to log of gx. And hence we can say that gx is equal to e power integral of p into dx. So this is the function which we have to multiply to such of the equation to find out the solution, which is known as the integrating factor. Similarly, we can find the integrating factor for the second form also. So similarly, we get the integrating factor for the type dx upon dy plus px is equal to q is e to the power integral of p dy. In this we will be integrating with respect to y. Let's learn the algorithm of finding the solution of the linear differential equation. The equation which is given to us, the first step we will take, reduce it in the form dy by dx plus py equal to q, or dx upon dy plus px is equal to q. The second step what we will do, multiply the equation by the integrating factor. The third step is integrate both the sides and find the solution. Now we will discuss one of the problem to find out the solution of a linear differential equation of first order. That is, here x into dy by dx plus y equal to x cube. This is for the first time. To find the solution of this problem, the first step is to convert into the standard form of the linear equation. Here we find x is multiplied with dy by dx, so we divide the equation by x. This will come as dy by dx plus 1 upon x into y equal to x square. Here we find that p is 1 upon x and q is x square. Then we have to find out the integrating factor. So we find here integrating factor, that is if, is equal to e to the power integration of p dx. That is equal to e power integral of 1 upon x dx, which is equal to e power log of x with base e. And we know the value of this is equal to x. Now the next step is to multiply this x in this equation. So we write multiplying equation number 1 by x. The equation comes as x into dy by dx plus y equal to x cube. And the next step is to integrate both the sides. We can write integrating both sides with respect to x. This side we can see that it will be if into y, that we have already learnt. And this side it will be equal to integral of x cube into dx. So this comes as if means x into y equal to x to the power 4 upon 4 plus c. If we divide this by x, we are getting the answer y is equal to x cube upon 4 plus c upon x. And this is the answer to the problem. Here we can also see why it is if into y, that is x into y. If we differentiate this x into y, this comes as x into dy by dx plus y into d by dx of x is 1. So we can also check it whether our answer is correct here on the left hand side or not. Now we discuss one problem based on the second type, and the problem is x plus y into dy equal to dx. For the solution, the first step is to to convert it into this form. For that, can we write this equation as dx upon dy equal to x plus y? Transposing this x onto this side, we can write this as dx upon dy minus x is equal to y. This is our equation number 1. And here we find that this is a linear differential equation, and here p is equal to minus 1 and q is y. So we find the integrating factor if, which is equal to e to the power p into dy in this case. That is equal to e to the power minus dy, which is e to the power minus y. After finding the integrating factor, we go to the second step, that is multiplying the equation by if. So we multiplying equation number 1 by e to the power minus y. The equation becomes e to the power minus y into dx upon dy minus x into e to the power minus y equal to y into e to the power minus y. In the next step, we integrate both the sides. So we write integrating both sides with respect to y. We know that the left hand side will become if into x and the right hand side will be y into e to the power minus y dy. On the right side, we have to apply integration by parts, for which this is u and this is v. So we find here this is e to the power minus y into x is equal to y into integral of e to the power minus y dy minus d by dy of y into integral of e to the power minus y dy whole dy, which is e to the power minus y into x is equal to, here it is y into minus e to the power minus y minus 1 into minus e to the power minus y dy. This is equal to minus y into e to the power minus y minus minus plus minus minus e to the power minus y plus c. Transposing this e to the power minus y onto that side, we are getting x equal to minus y minus 1 plus c into e to the power y. And if we transpose this here, we are getting x plus y plus 1 equal to c into e to the power y, which is the solution to this particular differential equation. So by discussing these two examples, we could understand how to find out the integrating factor and how to find out the solution of the linear differential equations. In the next video, we will learn how to form the differential equation for a given equation of curve. Thanks for watching my video. If you have any comments or doubts, leave them in the comment box and I will get back to you.